2017 higher level C3. So the image on the right shows a recycling bin in a shopping centre. The slope top of the metal bin is a transition piece made up of 2 trapeziums and 3 rectangles as shown. Figure C3A shows the plan and elevation of the transition piece. The 2 openings are not included. A one-piece surface development of the transition piece is also given in figure C3B down the very bottom there. Now part A, draw the given plan and elevation of the 5 surfaces of the transition piece. So I have that already set up on my page. The only thing to be aware of there is the scale is 1:6, so divide everything by 6. So 360 divided by 6 will be 60 millimeters, 90 divided by 6, 15 millimeters, and so on. Part B then, determine the dihedral angle between surfaces A and B. So we have A and B in the plan and elevation. The line of intersection between those surfaces is along here. Now what I am going to begin with, I will find that dihedral angle. But first of all, my line of intersection, I'm going to label it as the line 1, 2. My second part there, instead of bringing all 4 corners of surface B and all 4 corners of surface A, I am actually going to just divide those and create 2 triangular surfaces. And I'll just highlight that there in the elevation as well. And then I'm going to label there point 3 and point 4. Next step then, as always, our line 1, 2 is the line of intersection. We need to find the true length of that line, so we look perpendicular to it. Now as that is vertical there, all I need to do is to project perpendiculars, bring my horizontal lines across there. There's my x1, y1. Height from the elevation, point 2 doesn't have a height. Points 1, 3 and 4 all have the same height. And I have 1 and 4 are perfectly in line, and there's point 3. There's my line 1, 2, and I will just label that now as a true length line. And then I'll draw my surface B there. So joining 1, 2 and 3 will give me surface B. My second step then, for my dihedral angle, is to look along my true length line. So my line of intersection I will now project along that line, and I will view it then as a point in my next view. Now I am also going to put in, instead of measuring my distances the whole way back from my x1, y1, I am going to put in a datum line. Point 3 there. And just remember and label your datum line DL. I will measure the distance then for point 4. Line 1, 2, which will now appear as a point. And point 3 is on my datum line. So there's 3. And that then is my dihedral angle. And remember to measure that and indicate what angle it is also. So that is part B of the question now complete. Part C, determine the true length of the shortest diagonal on surface C. Hence, using triangulation or otherwise, draw the given one-piece surface development of the transition piece as shown in figure C3b. So this is what they're looking for, that we draw the one-piece surface development of it. Now, first of all, I'm going to break this into two parts. So determine the true length of the shortest diagonal on surface C. So that's step one. So this here will be the shortest diagonal. I have two diagonals on surface C. That would be one. This will be the other. Obviously, that one there being the shorter of the two. So I'm just going to draw in that short diagonal first. There's the shortest diagonal. Next step then, to find the true length of that short diagonal, I will rabat the line around. I rotate it around. Now there's that point here is up at the top of the object. This point here would be on my XY line. So when I swing that point around, bring it up there to where it hits my XY line, shine it up to the top, and that there is the true length of the shorter diagonal. Now, my next step then, I need to draw the one-piece surface development of it. What I am going to start off with, I'm going to begin with surface A, and I'm just going to draw that down the bottom, directly underneath there. So what I will actually do, the width of surface A, I can see it exactly, so I'm just going to drop that straight down there underneath. And my line 1, 4, I'm just going to keep that horizontal. Now, the true length of 1, 2. So surface A is a rectangle. I have the width of that rectangle. I need to find the height of it here for how far it comes down. Now if we think back to part B of the question, 1, 2 was the line of intersection between A and B. I found the true length of 1, 2 over here. So all I'm going to do is take my compass then, measure the length of the line 1, 2, and I'm going to step it off there. And that there is what we would call the true shape of surface A. Next thing, I am going to do surface C off to the side here. Now, what we have done by drawing this pink line here, the shorter diagonal, we've divided C into two triangular surfaces. I have this line already on my development here. I also have the true length of that pink line. I found that there for the first part of part C. So I'm going to measure the true length of the shorter diagonal with my compass, and I'm just going to swing it off there. Next step, I want to know what the true length of the short edge on surface C is. Now if we look, that edge is horizontal in the elevation, therefore it is a true length in plan. So I can measure the length of that line in plan, and I'll just swing it off. Now what I am going to do then is I'll just darken in the top part there. If you want, you could lightly draw in there your shorter diagonal. Next step then, I want to complete surface C. If we look at this line along here, because it is parallel to the XY line, we're looking 90 degrees at it, we will actually see the true length of that line in the elevation up here. So straight away I'm going to measure that with my compass. Swing it off. That baseline on surface C, it's horizontal in the elevation, therefore it is a true length. Which we would swing off there. And that there then would be the true shape of surface C. Next part then, we just have this rectangular surface. The actual width of that, or how far it comes off there from C, I can measure. As you notice, it's a rectangle, both sides are parallel. So all I'm going to do there, slide and set squares. Go perpendicular there. Measure it with my compass. Step it off. And as I said, it's parallel there. And that will be 1/2 of it. Now, to find surface B, you can just do the exact same thing pretty much. You can just take these measurements, step them off on the other side. So I'm just going to pause this and quickly work ahead and do that.